Yes, before going to the high impedance probe, so we just revisit the first two types of probes. So what is the advantage of first probe and what is the limit of first probe, and then what is the necessity to go for the third probe, that is high impedance probe. So now just revisit the previous class so that we will have the continuity to understand the present probe. So first probe is direct probe. So we are saying that 1:1 is a ratio. This number specifies the ratio. The ratio is input impedance and output impedance. Input impedance of cable or probe, and this is output impedance. So what is the ratio of input output impedances of cable? So here when you use the direct probe, the impedance of the signal may not be changed, right? So that we can see in this last statement of this slide. This type of probe does not provide any improvement in the input impedance. So when you are using this direct probe, there is no change in the input impedance. So whatever the signal, whatever the circuit impedance, output impedance, the same thing is carrying out and connected to the CRO. There is no change in the input impedance. See here, even it is not changing the input impedance, but there is some change in the capacitance. When the direct probe, see this blue color statement, when the direct probe is used, the input resistance remains constant, that is CRO resistance. CRO resistance is 1 mega ohm. 1 mega ohm. The general CRO input impedance is 1 mega ohm. But the input capacitance of oscilloscope gets added to the probe capacitance. See, even it is not changing the input impedance, but some additional capacitance is going to add with the CRO capacitance. That makes some changes in the performance of CRO. So to avoid this, added capacitance, some mechanism is required, or some additional components is required to compensate this change in capacitance, added capacitance, right? See here. So to compensate this capacitance, we are going to add one resistor in series with the input side, that is called isolation probe, the second type of probe. The main reason to go for isolation probe is to reduce or to compensate the increased capacitance while using the direct probe, that is 1:1. See here, of course, this isolation probe uses one resistor in series at the input tip side. So this resistor is carbon resistor. So because of this added resistor, this carbon series resistor is reduces the oscillation up to some reduces the oscillations in the CRO screen, which is arises due to the addition of capacitance in the first type of probes. So this is reduced up to some extent. At the same time, this also has some limitations. So what is that limitation is, see, this isolation probe reduces the undesirable, you can see in this statement, an isolation probe is employed to avoid the undesirable circuit loading effect of the shielded probe, right? Shielded probe. But of course it reduces this. At the same time, it it adds some change in the amplitude. It changes some amplitude and changes in the wave shape. See, once I will use pen so that See, slight change in amplitude of the waveform and slight change in the wave shape. It because of using this isolation probe, it reduces this undesirable circuit loading effect, which is arised in the first type of probe, and it also causes some changes in the shape of wave and amplitude, right? So this is also not required or not expected in the real-time environment. So to avoid this also, okay. So to avoid this, a high input compensated probe called low capacitance probe or 10:1 ratio probe is used. 10:1 probe is used. So that 10:1 probe so is also known as high impedance or 10:1 probe. So that is what now we are going to discuss it, right? So the 2 points we discussed in the last class, right? So just for your understanding purpose, I just explained those 2 points, right? See here. So now we start our current topic, that is third one, high impedance or 10:1 probe. So just observe this circuit construction here. So this is the circuit of the probe. So here input, we are applying input here. Yes, wherever you want to take the output from your circuit. So at that point, this point is connected to the circuit, so that the signal, the voltage or amplitude of that particular point is transmitted through this cable and then connected to CRO input. So here we have a circuit. At input side we have a circuit, and output side we have a CRO. So we are discussing the probe which is used to connect these two, circuit and CRO, right? So in between this, so input means the circuit output. So we are connecting here, and if you see this, there is one parallel combination of R and C, parallel combination of R and C. So this parallel combination of R and C increases the input impedance, increases the input impedance. So R and C. How this improves or increases the input impedance? So parallel R and C combination, impedance expression we can write it as impedance expression Z is equal to R into R into that XC divided by R plus or we can write the square root of R square XC square, and here R is fixed, that is very high value, 9 mega ohms. R1 is fixed, and capacitor is made variable. So this compensation capacitor, this capacitor is also known as compensator capacitor. This compensation capacitor is used to reduce the added capacitance, so which is happened in the first type of probe, the added capacitance. So that added capacitance is compensated with this capacitor C1, and also in series with this combination we have one C2. So that is cable equivalent capacitance. Cable equivalent capacitance. Yes, cable equivalent capacitance. So now we have this first one is parallel combination of R1 and C. The impedance of that is Z. We can say that Z in input impedance of the cable. R into XL, R into XC divided by the square root of R square plus XC square, where XC is the reactance of capacitor C1, or we can say XC1. See, so this is a parallel combination, and second one is C2, and finally these two are in series, and then the signal transmitted at the point A. So input is connected here, and that signal is transmitted through the parallel combination of these three. Then the impedance of this point is Zin, and then the circuit, the parallel combination output we will see at point A. point A. So that point A, the signal at point A is connected through a conductor to the CRO side. CRO. Yes. So this is the general input impedances. R1, Rin is general input impedance of CRO. That is, this is only the specification of CRO. Rin is the input impedance of CRO. Cin is input capacitance of CRO. So generally, in most of the cases, CRO input impedance is 1 mega ohm and input capacitance is 10. That we can say that this specification of CRO. So now coming to this high input impedance, this probe is also known as passive voltage probe. Sometimes examiner may ask, explain a passive probes. So in the beginning of this beginning of this topic, that is in previous class, I explained that there are basically two types of probes. One is active probe and second one is passive probe. So active probe uses the active components like BJT, FET, operational amplifier at input side. So that is just now we discussed R1 and C1. So R1 and C1 is R1 is resistor and C1 is capacitor. So these two are active elements or passive elements. So R resistor, capacitor, inductors, we know that these are passive elements. So if any probe circuit uses RLC components at input side of its construction, then we can say that is passive probe. Because it is using passive elements at input tip of the probe. Suppose if the probe circuit uses a FET, that is field effect transistor, BJT, bipolar junction transistor, at input side of the probe circuit, then we can say that is active probe. So now just like we can classify the active probes and passive probes. That is only the based on components using at input side of the probe tip, right? So that's why this is known as passive voltage probe. The second point is the basic function of this probe is or the basic purpose of this probe is to increase the input impedance and reduce the effective input capacitance of oscilloscope. And finally here the capacitance should be 20 picofarads, so that should not change because of using this or connecting the probe with your CRO. The input capacitance of CRO should not alter or should not change, right? So to maintain this 20 picofarads as it is, so to here we are using a C1, right? Okay. So the main function of this probe is to increase the input impedance. So we can increase the input impedance with this relation. By changing the R and C values respectively, and reduce the effective input capacitance of oscilloscope, and reduce the effective that is added capacitance. In direct probe, the capacitor gets added, right? Is getting added. So to reduce that and to maintain the 20 picofarads as it is, so this circuit is being used. So the purpose of this circuit is, there are two purposes. One is to increase the input impedance, and second one is to reduce the added capacitance in the CRO. Yes, this probe uses a parallel resistor and capacitor combination. So that just we discussed it. The resistor R1 is shunted by an adjustable capacitor. This capacitor is also called compensating capacitor. So the arrangement of this, the resistor R1, C1 are designed in such a way that the input impedance increases by factor 10. See here, the input impedance increases by factor 10 and input capacitance is decreases by factor 10. Yes, input 9 plus 1, 9 plus 1. So that is input capacitance is decreases by factor 10 and input impedance is increases by factor 10. So that's why because of this factor, the name is also given as 10:1 probe. See here, 10:1 probe. The name of the circuit, circuit or probe. So it's given a 10:1 probe. So this probe uh, decreases the capacitance by 10 factor and increases the input impedance by factor 10, right? So therefore this combination is also called into 10 probe or 10:1 probe. So C2 is a probe cable equivalent capacitance, already we discussed. The input resistance and CRO can be referred to as Rin and C1. The typical values of Rin is 1, not megawatts, it is mega ohm, and 20 picofarads and 20 picofarads. So this is about the 10:1 probe. So this is a passive probe, and the purpose of this probe is to increase the impedance and reduce the capacitance. And so there is some arrangement, that is R1 and C1. So R1 is 9 mega ohms and C1 is called capacitance compensator, right? And finally it is used to connect the CRO, which is having input impedance is 1 mega ohm and capacitance 20 picofarads, right? So next probe is active probe. So just now I explained that active probes and passive probes. So 10:1 probe is called passive probe and active probe is, so that we are going to see now. So this active probe, so if you observe this construction, at input side of this we have FET source follower and second element is BJT emitter follower. There are two components. And two the circuits. So FET source follower. FET is active or passive element? Can anyone answer me?
Active, sir.
Yes. So that's why it is called active probe. So BJT is active or passive?
Active element.
Active element. So because of this construction, the components using in the construction of this probe, so this is classified as active probe, right? The same thing if you see the last case. So input side is only RC, but here there is FET, one is active component and BJT is one more active component. And the purpose of these two circuit is, first FET, as we all know that FET is having very high input impedance. So the advantage of high input impedance is it reduces the loading effect. Loading effect meaning is that, so the most important point in using a measuring instrument is always the measuring instrument should have high input impedance and output should be a very low output impedance. So the reason behind this statement is, so whenever a circuit is having high input impedance, then a device is having high input impedance, then whatever you are connecting this previous circuit, then the circuit function may not change because of this high input impedance component. Yes. See, the measuring instrument. So measuring instrument, suppose I have a circuit here. This is my circuit. Let's say this is circuit. This circuit is having some resistor and a capacitor. So now I am using one measuring instrument for this. So this is my voltmeter. I want to measure the voltage across this component. So then the input terminals of this voltmeter is connected to the capacitor across the capacitor, so that we can measure the voltage across capacitor. Suppose this device is having very high input impedance, that is, let's say 1 mega ohm of high input impedance. high input impedance, and this circuit is having, suppose let's say 100 ohms. 100 ohms is the output impedance. 100 ohms is the output impedance. Then this 1 mega ohm, if you use this 1 mega ohm, this 100 ohm resistor is the circuit impedance. So how this voltmeter is connecting with the circuit? How the voltmeter is connecting the circuit? Always the voltmeter
Parallel.
is connected across the component. Across the component means parallel combination. When the two components are connected in parallel, two resistors are connected in parallel, then their resultant resistance will get decrease. So then what happens? Then output circuit output resistance will get decrease. Once the resistance is decreased, then the voltage drop across it also decreases. Yes. So that's why this uh, high, suppose we are using high input impedance component, then this circuit resistance will not change, because the resistance is very high. Is a 1 mega ohm and 100 ohm. So parallel combination is 100 into 1 mega ohm by 100 plus 1 mega ohm. The resultant value is always equal or greater than this 100 ohms. So the resultant resistance may not decrease than the actual resistance value of the circuit. So that's why always we say that in electronic circuits, or whenever you are using some additional measuring instrument to measure the output voltage or amplitude of this circuit, then always it should have the very high input impedance. So that's why in commonly we say that in electronic circuit cases, so the measuring instrument should have the high input impedance and a low output impedance, right? So this type of problems we already explained, discussed in first unit itself, that is called loading effect. So there we have also seen some problems, how to understand this, loading effect, right? So after this class, we can just refer your notebook back and see the loading effect, right? So then we'll get clarity on this high input impedance or low output impedances. See here, active probe. So this FET is having very high input impedance. So if you use this FET at the input side of this probe, so then this probe is automatically having high input impedance. Once it is having high input impedance, then if you connect this probe to your circuit, then your circuit function will never get altered. Yes, your circuit function will not disturb. Whatever the output is there in your circuit, the same output is transmitted or carrying out by this probe and connects to the CRO. So that is what the advantage of high input impedance, right? Suppose you are using low input impedance components, then what happens? So suppose you are transmitting the 5 volts signal here, 5 volts signal, and only 3 volts signal or 4.5 volts signal may be displayed on the CRO screen. This 0.5 volts drop because of low input impedance components. So that's why you must take care whenever the device measuring instrument are choosing for measurement of certain parameter, it should have the high input impedance. So then only we'll get the accurate. Second one is the impedance matching circuit. This BJT is using as a emitter follower circuit, as already we know that we might have studied in your previous semesters. Is a impedance matching circuit. Voltage follower, emitter follower, or you can say that voltage follower. So is a buffer amplifier. Yes, buffer amplifier. Input and outputs are same, that is unity gain amplifier. So the reason is we are not using for amplification, it is using for only the impedance matching of the circuit. Impedance matching means here FET circuit and here CRO circuit is there. CRO circuit. So this is CRO up to from here it is CRO, and this is input of this side is input. So the impedance matching of these two input is also very important. This is having very high input impedance, and this is Rin is a 1 mega ohm, 1 mega ohm. So that is to match the impedances. So BJT emitter follower circuit is using in between FET and CRO blocks in the active probe. See, the active probes are used for connecting one specific point. Why this is using in the circuit? So the active probes are used for connecting fast rising and high frequency signals. Second one is these probes are very useful for small signal measurements, and their attenuation factor is very small. Whenever a small signal we are measuring, then we can choose this type of probes. So next, the active probe consists of an active element like FET source, as we discussed just now. This active element probe consists of an active element like FET source and BJT emitter follower circuit along with a coaxial cable. The FET source is provide high input impedance, which reduces the loading effect. The BJT emitter follower, so it drives the impedance matching circuit, right? So this is about the two types of probes, that is what we are discussing here. First one is 10:1 probe and high impedance probe, and second one is active probe. So simply we can say that. So now in this class we discussed the two types of probes. One is passive probe and second one is active probe. So examiner may also test your understanding level. Explain the active and passive probes of CRO. Yes. So then you're supposed to write these two types of probes, right? So in this class, we studied about the two types of probes. So high impedance and active probe. And there are some more probes also there, current probe, but actually it is not there in your syllabus, current probe. So current probe means simply the current probe is converted into voltage. The current of your circuit point is connected in the voltage, right? So then it is connected to CRO. So this is not there in your syllabus. If you want to see, or if you want to just know about it, so then you can go this. Otherwise, you just leave it, right? Current probe and differential probes. So these two are some additional probes that I have given here for your understanding purpose. So these two are not required for examination point of view. So if you want to understand it or to know about it, so then you go to this, right? If anybody requires these two, then I will explain these two in the next class, right? Otherwise, you will go to the next topic. Okay. So with this, I just I conclude my this session. Yes, four types of probes are very important. So very simple. So I have given the enough points here so that we can directly read these statements or read these points. So you can write the same thing in examination also, right? So no need of any additional material to this topic. The complete material I have given here. So I will post this into WhatsApp group of third year ECE. So you can share with your friends. Yes. Okay. Anybody is having doubts? Just anybody, if you have any doubts or any points to be understood, so then you just write me in WhatsApp group. So I will explain you in next session. Okay.